Hey guys, got some free time today, so thought I'd teach logarithmic differentiation finally and send over a video from the bottom of Zermatt. Actually, that's the Matterhorn over my left shoulder. It's really cool to look at. Everywhere I go, I can't stop looking at it. So um, as I come closer, I think it might disappear. But anyway, so let's go over logarithmic differentiation. We'll start by reviewing three of the most important log properties, which is the law of products, the law of quotients, and the the law of powers. So the law of products says that if you are taking the log of a product, then you can split it up as the sum of the individual logs. So log of xy will turn into log of x plus the log of y, and then the log of x over y, which is a quotient, turns into the log of x minus the log of y. The way that I remember it is, if it's in the denominator, then it should get a minus sign. But if it's in the numerator, then it should get a plus sign. And finally is the law of powers, which says that you can throw the exponent out front of the log. So the log of x to the n turns into n times the log of x. So let's use that now to figure out how we can change the expression log of x to the a divided by y to the b and z to the c. So there are three factors here, but the y and the z powers, those are in the bottom, so we're going to give those minus signs. So this will turn into it'll turn into a times the log of x, that's in the numerator, so it's a plus sign, and then minus b times the log of y, and minus c times the log of z. So why do we want to review these log properties? That's because sometimes a new technique that you can use is logarithmic differentiation, which helps to simplify the process for taking really complicated derivatives. For example, the one that I've given here is use logarithmic differentiation to differentiate this large expression, 2x minus 1 to the 2, square root of 3x squared plus 1, and all over x minus 3 to the 4. That would typically be a very hard derivative because you would have quotient rule governing the entire outside. You'd have a product rule when you took the derivative of the top, or for f prime, and then you keep on having all these chain rules because you've got it to the squared, you've got it to the square root, and you've got it to the 4. So what we can do is we can take the ln of both sides to change what this looks like. It'll change the right side into a sum and difference of individual terms that we can take the derivative of. So if we take the ln of both sides, we get the ln of y is equal to, so whatever we do to the right, we have to do to the left. This will turn into, now, if you take the ln of this, it's going to be 2 times the ln of 2x minus 1. That's in the numerator, that's why it's a positive. So as well as this, plus 1/2, because remember that a square root is really an exponent of 1/2, times the ln of 3x squared plus 1. And then we have this x minus 3 to the 4, that should be that's in the bottom, so it's going to get a minus 4 times the ln of x minus 3. Now we can take the derivative of the right side as well as the left side. Notice that y is no longer alone, so we cannot use normal differentiation, explicit differentiation. We have to use implicit differentiation. So we take the derivative of both sides. What's the derivative of ln of x? It's 1 over x. But what's the derivative of 1 over y? Remember, it's 1 over y times y prime. You have to remember to add that y prime in because we're using implicit. So on the left side, we're going to get 1 over y times y prime equals to, now, what's the derivative of a ln? Of like ln of 2x minus 1, or ln of a function. It's 1 over the function times the derivative of the function. So we get 2 times 1 over 2x minus 1 times the derivative of the function, which is 2, plus 1/2 times 1 over 3x squared plus 1 times the derivative of 3x squared plus 1, which is, of course, 6x. Whoops, sorry guys. Which is 6x. Shift this down a little more. Then we have minus 4 times 1 over x minus 3. Now that, the derivative of the inside on that, the derivative of x minus 3 is just 1, so we don't really need to write anything. So we can simplify this a little bit. We can go 1 over y prime is equal to, now 2 times 2 times 1 is going to be 4, so we get 4 over 2x minus 1, plus a 1/2 times 6x, that'll turn that into a 3x over 3x squared plus 1, and then minus 4 over x minus 3. Now, after you differentiate both sides, what's your job? It's to get the y prime alone. How do we get rid of that 1 over y that's being multiplied to the y prime? You would multiply it by y. If you multiply both sides by y, right? If you multiply this by y, the y's will cancel out, right? So basically, we're going to multiply by y on both sides, and that'll get rid of the 1 over y. Shoot. Now, y prime is alone, and you're pretty much done. But we like to get an expression for y prime, if we can, that has only x's in it. Right now, there's that y at the end. So instead, what you want to do is you'll use the original function in the place of y. So remember that y is equal to this original function here. So we will put that in its place. Instead of writing the y at the end, we're going to go 2x minus 1 squared times the square root of 3x squared plus 1 all over x minus 3 to the 4. And now that's an expression that's only in terms of x. That's what we want. We're done.